In this video, I will be explaining how to compute the nominal rate of interest if we know the present value, we know also the future value, that could be our goal, and we know how long will be the investment. If we have this information, how to compute the nominal rate of interest. I will be explaining this with 3 examples. The first example will be this. If a deposit of $7,000 grows to $9,308 in 3 years, determine the nominal annual rate of interest compounded monthly. And I will be using the formula of future value for doing that. The formula of future value that we know that we have the periodic rate of interest here in this factor, the compounded factor. We have here the present value, and we know here the number of compounded periods in the term, in these 3 years in this case. So if we write this with the nominal rate of interest, instead of I can write R over M. M will be the number of compounded periods in 1 year. Here what we want is to compute a nominal rate of interest. So we need to use this formula solving for R. So we use the formula of compound interest, but now take into account that we know the present value, that is 7,000. Let's type here what we know. We know the present value, that is 7,000. We know also that the future value is 9308. We also know that the term is 3 years. We are looking for the nominal rate of interest, R, but this nominal rate of interest is compounded monthly. So we know this M that is here in the formula. So M equal 12. It's compounded 12 times per year. And we know the time that helps me to know how much will be N here in the exponent of the formula. So the time is 3 years and is compounded monthly, so the time is N will be 3 times 12 equals 36. So N will be 36. With this information, I can use this formula and solve for R. That's what I'm going to do. So type the formula, substitute everything. This H is $9,308 equals 7,000 multiplied by the compounding factor. Remember, R divided by M to the power N. And for solving for R, the first things that you need to do is divide by the present value, divide by 7,000. So dividing by 7,000 both sides, you obtain this. And this will be equal just the compounding factor. Now that you have this, another thing that you can do immediately is divide the exponent by 36. Because if you divide the exponent by 36, both sides, here the exponent is 1, the new exponent will be 1 over 36. So at the left side, we're going to have this fraction to the power 1 over 36. And at the other side, the exponent will be 1. So it will be just 1 plus R over 12. Now that you have R over 12, solving for R is easy, and you can subtract 1 both sides. So at this side will be minus 1. This 1 disappears. So we have that R over 12 is this number minus 1. And then multiply everything by 12. So if you multiply everything by 12, this is the answer, and then use your calculator. That's it. That gives you the nominal rate of interest. So I use my calculator, I will obtain this number, and I'm going to multiply this number by 100. If I multiply this by 100, the answer will be in percent. So the nominal rate of interest will be 9.5365 compounded monthly. So if you put the money in this nominal rate of interest compounded monthly, you are going to obtain this $9,308 at the end of the 3 years. Let's solve other examples. The new example will be this. If a deposit of 5,800 grows to 8,105 in 7 years, determine the nominal annual rate of interest compounded semi-annually. Again, we start with the formula that we know, the future value formula, and we just take note of whatever we know. We know that the present value is $5,800, that the future value is $8,105, and that happened in 7 years. We need to find the nominal rate of interest, and that nominal rate of interest that we need to find is compounded semi-annually. So m equal 2. We know m equal 2, and we know that n, the number in the exponent here, will be the time times 2. So it will be 14 compounded periods. 7 years times 2, 14 compounded periods. Make a substitution in the equation, and this is the number that you're going to have. You don't need to type the dollar signs because they will cancel. So if you divide by 5,800, this is what you obtain. At the other side, we have the compounding factor. The first things to do is divide by the present value. Now that you have this, in order to solve for r, you can divide both exponents. You can consider that this exponent is 1, yeah? So 1 over 14 it will be the exponent on the left side. On the right side will be 14 over 14, that will be 1. So this is what we are going to have after we divide the exponent by 14. And then this 1 can be written at the other side subtracting. So you have that r over 2 equal this number minus 1. So you can, this is subtracting 1 both sides. And then multiply by 2. If you multiply by 2, this is the answer, and then you use your calculator. Using your calculator, you obtain this number. This is 4.8379%. So multiply by 100 to type the answer in percent. And that's it. So let's do a final example in case that we need to find the effective rate of interest. Imagine that we have both future value, present value, but we want to know the effective rate of interest. We know the present value, the future value, and the time, the term. And we want to compute what will be the effective rate of interest. Let's think in this problem. If a deposit of 5,800, the same, grows to 8,105 in 7 years, determine the effective rate of interest. What to do in this case? That the problem is effective rate of interest. Okay, so we can start with present value, that is 5,800. The future value is $8,105, and now we need to compute the nominal rate of interest, because actually the effective rate is the nominal rate of interest compounded annually. So it's the rate that gives me the rate compounded in 1 year. What is the amount of money that we receive for $100 in 1 year? So m equal 1. If somebody asks me what is the effective rate, I will be using m equal 1. And then it will be doing the same. The number of compound periods, n will be 7 times 1 will be 7. So the formula is this, so I can make a substitution, but now this r will be r divided by 1. You can write effective rate, you can write f if you're using f as effective rate here. And then solve for r or solve for f if you have f. So I divide everything by 5,800. Then this fraction will be equal to the compounding factor, and then divide each exponent. Consider that exponent on the left side is 1. So divide both exponents by 7. So if you do that, this side will be just 1 plus r. This side will be 8,105 over 5,800 to the power 1 over 7. And now that you have this, just solve for r, so this one go to the other side. That's it. Use your calculator now. If you use your calculator, the answer is 0.4896. 4. So you can say in percent will be 4.8964%. So multiply this number by 100. When you multiply by 100, this is your answer. Round it to 4 decimal places. And with this example, I finish my explanation. Thank you.